Hey everyone, welcome back to the channel. Today we are diving into the world of advanced machine learning classification problems. So whether you are preparing for an interview or looking to enhance your machine learning skills or just to have a good challenge, this video is for you. So we are covering the top 5 advanced classification questions which are generally asked in the machine learning interviews. So before we start, make sure you subscribe to our channel. So now let's get started. So we'll go with the question number first. That is, how do you deal with the imbalanced classes in classification problems? So first up, an important challenge in many real-world classification problem, that is imbalanced classes. And what is meant by imbalanced classes? So when one class dominates the other, the model might end up predicting only the majority class. And this leads to poor performance, especially when predicting the minority class is critical. So here's to handle few ways to handle the imbalance class. First one is the resampling method, and that includes like oversample the minority class and undersample the majority class. The second option is the synthetic data generation with the method called SMOTE, synthetic minority oversampling technique. It is very popular. The third was use of the class weight. So many models such as random forest and SVM allow you to assign different weight to a class to make them more equally important. Let's see the example using SMOT and the random forest. So let me load the libraries. Here you have to use the Imbalanced, which has the oversampling class, and you can import MSCT from there. Now after that, let's generate some data with the imbalance classes. So as you can see, I have provided the weights here, and there are two class types. Next, we are just splitting the data, and in the next cell, apply SMOT to balance the data set. And I'm creating a new X train and Y train from resampling by using the SMOT. So after training the random forest on the balance class, let's predict and evaluate the model. So in this case, we might get the perfect score, which is fine, but that's how you use this SMOT to re-imbalance your classes, and if they are imbalanced, to balance the classes. Let's move to the next question. How do you tune hyperparameter for classification model? So next we have hyperparameter tunings. One of the most important skill in machine learning is knowing how to tune your model hyperparameters. Without this, even the best algorithm might underperform. And for this, there are two main techniques for tuning. The first one is the grid search. It tests all the combination of parameters. And the second one is the randomized search. So it randomly sample hyperparameters, offering faster result with larger search spaces. So let's see the same one of the code using the grid search CV, and let me load and create a model classification for random forest classifier. And these are the hyperparameters for the model. So the number of estimators are 100, 200, and 300. This is the maximum depth of the random forest, and the minimum sample is 2, 5, 10. And let's create and fit our model and see what are the best hyperparameter for this. So using this, you can hypertune your classification models. Next question, let it run, and we'll move to the next question. Meanwhile, what is the cross validation and why it is important in the classification? It is one of the main question. Okay, so this is, and we got the best parameter for the grid search. Now moving to the cross validation, one of the best technique for evaluating the performance of classification model. So cross validation involves splitting your data into multiple subsets or folds. The model is trained on and some folds and validated on remaining folds. So this process is repeated several times to ensure the model is not overfitted or underfitted. So there are two main types, the k-fold validation. The data is split into k subsets, with each subsets being used as a test set once. And this next one is stratified k-fold, ensure each fold has proportional representation of each class. Let's see the code example using k-fold cross validation. So let me run and import the classifiers and perform the five-fold cross validation. And I got the accuracy, cross validation score, and the average accuracy, which is almost perfect. Now let's move to the next question. How does a decision boundary work in the classification algorithm like SVM? So it's, this is the decision boundary. These are the support vectors, and this is the margin. So to refresh, a decision boundary is a hyperplane that separates classes into feature space. The model tries to find the boundary that minimizes and the margin between the classes. So again, there are two ways you can do it. Uh, Generally, like linear SVM works when classes are linearly separable, and the next one is the non-linear SVM. So it uses technique like RBF kernel to map data into higher dimension space where classes are separable. Now let's move to the last question. How do you interpret a classification wording using a SHAP values? So SAP, this is sharply additive explanation. Values are a powerful way to explain prediction, especially for complex model like random forest or gradient deposting. Such SHAP value assign an important value to each features for every prediction, allowing you to see which features has the most influence on the model output. So SAP for a feature importance, visually you can visualize the feature importance and see which features contribute positively or negatively to prediction. So let's see the code example for this. So in this, let's load the SAP library, and here I'm just loading the random forest, make classification to generate the data, and to split the data, train test split. So after splitting the data, let's train the random forest model. And next, initialize the SAP explainer. Let's calculate the SAP SHAP values. And lastly, let's plot the summary. So SAP, just to give some explanation, SHAP tree explainer for tree model like random forest. The SAP value here is a list where every entry corresponds to SHAP value for a class. So in this case, if a class 0 is a negative and 1 is the positive. And this summary plot, we are visualizing the SAP value for class 1 and 2, right? And this is a positive class for a binary classification. So if you want to visualize 0, simply we can add only 0 here. Yep, that's it for today. These are some of the important questions which are being asked in the classification, related to classification in the machine learning interviews. I hope you like it. Thank you for watching. I will see you in the next one.